So what we have in front of us here on the screen is one of the spotting plates. Now you can see there the red and the blue litmus, and quite obviously at the moment they're different colours. So what I'm going to do is similar to what you guys did. I'm going to introduce a couple of chemicals. And so the first I'm going to do is the hydrochloric acid. Now of course we can predict what's going to go on here, so that first one there, try not to stick on there. So obviously what has happened there when I put the acid in? What's happened to the litmus? It's gone red. Now, one of the things there, now if I put in a drop of universal indicator as well, can you guys predict what the colour is going to be?
Red.
Reds, so we're going to say it's going to be at the red end. So we put our green bit in there, and quite obviously, that's gone red. Okay, so what is a general thing we can say about acids in terms of litmus and things and universal indicator in there? What was that say?
They're warm colours.
Oh, you're an artist too, aren't you? Yes, so they're the warm colours. It starts the oranges, the yellows, the reds, and that there as well. The other chemical I'm going to put on the right-hand side of that is sodium hydroxide. Do we have any predictions?
Red.
Red? You're going to say the sodium hydroxide is going to turn red? Let's have a look. Okay. Now, 1, 2, 3. Okay. Now, we've got here that the litmus has gone that purpley blue colour. What colour do you think the universal indicator is going to go? Purplish or whatever. Okay. Now, okay, I might just put another drop of the sodium hydroxide in there. Just, you can see though, it has gone that dark colour. It actually, yeah, it's gone that dark purpley blue. Now, that is there. Sodium hydroxide is a base, or as we had before, it's in the Year 12 textbooks, it's an alkali. It's basically the same thing. There's subtle differences in there. So I'm going to take some sodium hydroxide. What's going to happen when I put it in the acid? I'm going to have a prediction on what might happen there. No explosions, nothing exciting today. Neutralization reaction, possibly. Let's just do it a little bit of a drop there. What can you see anything happening? Yeah, let's put another drop in there. Let's put a lot of drops in there.
Wow.
Okay. What has happened in there? What do you think? What do you think the chemical change might be? Is that loud? The pH level has risen. It's gone from being an acid to being a base. And the thing about this here is that pH levels. So when scientists examine cooking and things like that, a lot of cooking is about changing pH. There's some cooking techniques. One involves you can actually, in inverted commas, cook fish by putting citric juices on them. Because what the citrus does, and it's usually citric or tartaric acid, actually changes the chemical nature and changes it a little bit. Now what's going to happen when I put the acid in the base there on the right? Nothing. Or it's going to go red. Now, that's not amazing, it's just chemistry. Not particularly. If I was going to be really amazing, I could actually try.
Make an explosion.
No, we don't do any explosions here. If I'm able to do it carefully, I can almost get it to be green. Very tricky to do, but it's not quite going to get there. But you can see there, you got a little bit there. We've got a little bit of the red, a little bit of the blue there, and so you've got there that part of the solution is still a little bit basic. Part of the solution is still a little bit acidic. Okay, so that is pretty much that there.